Scientists use the metric system to make measurements during the experiments and tests that they perform in their work. In this lesson, you will learn about the important scientific measurements commonly used. In the metric system, the standard unit of length is the meter, identified by the letter lowercase m. Another common unit of length is the centimeter, identified by the lowercase letters cm. 1 meter is equal to 100 centimeters. For shorter lengths, scientists use the unit millimeters, identified by the lowercase letters mm. 1 meter is equal to 1000 millimeters. This diagram of the end of a metric stick shows the centimeter and millimeter markings. This table shows the standard measures of length and distance. The left column has the conversion units, while the right column shows the tool used to make the measurement. There are 1000 meters and 1 kilometer. The kilometer is used to indicate the distance between points to a driver on a road. The unit of kilometers is used on roads throughout the world. However, in the United States, the distance is usually shown in miles. 1 kilometer is equal to 0.62 of a mile. 1 mile is equal to 1.61 kilometers. There are 100 centimeters in 1 meter. The prefix centi comes from the Latin word for 100. The metric stick is used to measure centimeters. There are 1000 millimeters in 1 meter. The prefix milli comes from the Latin word for 1000. The shorter metric ruler is normally used to measure millimeters. There are 10 millimeters in 1 centimeter, and the metric ruler is normally used to measure centimeters. For the measurement of very small distances, scientists use the micron, which represents 1/1,000,000th of a meter. The micron is designated by the lowercase Greek letter for m, pronounced mu. There are 1000 microns in 1 millimeter. The optical microscope can be used to measure small distances, but the electron microscope, shown in the photo on the bottom right, is commonly used today to measure microns. The standard of time is the second, designated by the lowercase letter s. For times that are less than a second, scientists use milliseconds, and for times shorter than milliseconds, they use microseconds. The metric unit of mass is the kilogram, designated by the lowercase letters kg. There are 1000 grams in 1 kilogram. The prefix kilo is derived from the Greek word meaning 1000. The mass of an object is the same throughout the universe. As we will discuss shortly, mass and weight are different, although they are connected. Weight is a force. The weight of an object is equal to the force of gravity between the object and the Earth, or other planet where the object is located. Unlike mass, weight changes. The force of gravity on each planet is different, so the weight of an object is different from one planet to another. A person who weighs 150 pounds on Earth, would weigh just 57 pounds on the planet Mars. The connection between weight and mass can be easily calculated. The metric unit of weight is the Newton, designated by the capital letter N. The unit was named after Sir Isaac Newton, a British mathematician, astronomer, and physicist, who is widely recognized as one of the most influential scientists of all time. The weight of an object in newtons is equal to the mass of the object in kilograms, multiplied by the force of gravity of the planet where the object is located. On the Earth, the force of gravity is 9.8 meters per second each and every second. This is expressed as 9.8 meters per second squared. If the mass is given in kilograms, then the weight will be equal to the mass times 9.8. Now let us look at how the metric system of mass relates to people and things. An average person can have a mass of 50 or 60 kilograms. This would be equivalent to 50 or 60,000 grams. A single egg has a mass of 45 to 50 grams. A tiny grain of sand has a mass of about 12 micrograms. This would be equivalent to 12 millionths of a gram. Now, let us look at the measurements of temperature. The standard international unit for temperature is degrees Celsius, designated by a capital C with a superscript O before it to denote degrees. Degrees Fahrenheit is mostly used in the United States by the general public. It is designated by a capital F with a superscript O before it to denote degrees. The conversion from degrees Fahrenheit to degrees Celsius or vice versa uses the equations shown. To find degrees Celsius, subtract 32 from degrees Fahrenheit and multiply by 5 divided by 9 or 0.56. To find degrees Fahrenheit, multiply degrees Celsius by 1.8, then add 32. The third unit of temperature used by scientists is the Kelvin, designated by the letter K. The Kelvin scale is based on absolute zero, the temperature at which all particle motion ceases. Therefore, the temperature in Kelvin is always expressed simply by the capital letter K with no degree sign. To convert to Kelvin from degrees Celsius, simply add 273 to degrees Celsius. The chart on the right shows the three scales of temperature depicted side by side. Note that the freezing point of water is 32 degrees on the Fahrenheit thermometer, 0 degrees on the Celsius thermometer and 273 on the Kelvin thermometer. The diagram also shows the temperature measurements for boiling water, the highest temperature in the United States, the surface of the Moon, and absolute zero on all three scales. The metric units used in the scientific laboratory for measuring volume are the cubic centimeter and the liter. Cubic centimeters are commonly used to measure the volume of solids and gases. When measuring the volume of liquids, the milliliter is the most commonly used unit. The unit conversions are shown below. There are 100 deciliters in 1 liter. The symbol for deciliters is lowercase dl. There are 1000 milliliters in 1 liter. The symbol for milliliters is lowercase ml. 1 cubic centimeter is equal to 1 milliliter. The cubic centimeter is designated by the lowercase letters cm, followed by superscript 3. More measuring tools that scientists use in their laboratories are shown in these photos. The digital balance and the triple beam balance are used to measure the mass of materials. The volumetric flask and the pipette are used to measure a finite volume of a liquid. Graduated cylinders measure exact quantities of liquids. They come in various sizes, so scientists can use the one that most closely fits the desired volume being measured. The burette is generally used to dispense a precise amount of liquid during an analytical experiment to determine the concentration of a substance in a solution. This type of experiment is known as titration. The microliter syringe is mainly used to dispense very small, but precise amounts of liquids into a gas chromatography apparatus, which is used to separate the components of a solution. Now let us discuss the accuracy and precision of measurements. The accuracy of your measurement is half of the smallest interval marked on the tool. As an example, let us assume that you measured the length of an object with a metric ruler. With a metric ruler, you can clearly read the millimeter markings, but the spaces between them are not marked. Therefore, the accuracy of your ruler is plus or minus 0.5 millimeters or 0.05 centimeters. If the true length of the object is 10.17 centimeters, then you would record the measurement as 10.2 centimeters plus or minus 0.05 centimeters. Precision is often called a measurement of reproducibility. How precise is your measurement? For example, you measure the mass of a piece of steel 3 times and get masses of 50.2 grams, 50.4 grams and 50.3 grams. When you record the data, always make sure that units, in this case grams, follow the number. In science, all numbers must show the units. When you take the average of the 3 masses by adding them together and dividing by 3, you get a value of 50.3 grams. Therefore, your measurement is precise to plus or minus 0.1 gram. There is no such thing as a perfect measurement, so it is important to know both the accuracy and precision of the measurement. When making scientific calculations, the units associated with each number must balance, as we will show in the following example. A runner reaches a velocity of 10 meters per second toward the west, 20 seconds after he starts. How far does he travel? The distance, d, is equal to the velocity, v, times the time, t. In this equation, we substitute 10 meters per second for the velocity and 20 seconds for the time. Note that the seconds in the denominator of the velocity and the numerator of time cancel each other out, so we are left with the distance in meters. Therefore, the answer is 200 meters. This presentation was produced as a public service to help middle school and high school science teachers develop experiments and demonstrations that can be used in their classrooms. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. TOPS, Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by middle school students.